We know that one and only one tangent can be drawn through a point on the circle. Now, can you recall the defining properties of a tangent? The defining properties of a tangent are: firstly, a line is said to be a tangent to a circle if it touches the circle at exactly one point, and this point is called the point of contact. Secondly, at the point of contact, the tangent is perpendicular to the radius of the circle. In fact, the second defining property of a tangent can be stated as a theorem. Let's state this property as a theorem and prove it mathematically. Theorem states that a tangent at any point on a circle is perpendicular to the radius through the point of contact. It is given that xy is a tangent to the circle at point P and OP is the radius of the circle. We have to prove that OP is perpendicular to xy. Let us first consider a point other than P on line xy. We label the point as Q and then join OQ. The point Q must lie outside the circle because if Q lies inside the circle, xy will become a secant, whereas we are given that xy is a tangent. Point Q lies outside the circle, whereas point P lies on the circle. So, OQ is longer than the radius OP of the circle. If we take any point on the line xy except point P, OP is the shortest distance among the distances from point O to the points on xy. Therefore, OP is perpendicular to xy. Can you recall how many tangents can be drawn from a point outside the circle? Exactly 2 tangents to a circle can be drawn through a point lying outside the circle. In this example, PS and PT are the tangents from the external point P to the circle. For tangent PS, Q is the point of contact with the circle, and for tangent PT, R is the point of contact with the circle. The length of the segment of the tangent from the external point P to the point of contact is called the length of the tangent. Here, PQ and PR are the lengths of the tangents from point P to the circle. Are the lengths of the tangents equal? Let's measure the lengths. Observe that both the lengths are equal. Let's prove this result using the concept of congruent triangles. We will also use the same proof to prove some other statements related to tangents from an external point to a circle. We can use the same set of steps to prove these 3 theorems. If 2 tangents are drawn from an external point to a circle, then the lengths of the tangents are equal. The tangents subtend an equal angle at the center of the circle, and the tangents are equally inclined to the line segment joining the point and the center of the circle. It is given that point P lies in the exterior of the circle with center O. PA and PB are 2 tangents drawn from point P to the circle such that they are inclined to PO, and also the tangents are making angles at the center of the circle. We have to prove that the lengths of PA and PB are equal. Also, we have to prove that angle AOP is equal to angle BOP. Similarly, to prove that tangents are equally inclined to the line joining the point and the center of the circle, we have to prove that angle APO is equal to angle BPO. In triangles OAP and OBP, OA and OB are the radii of the same circle and hence are equal. As a tangent is perpendicular to the radius of a circle at the point of contact, angle OAP and OBP each measures 90 degrees and therefore are equal to each other. Also, side OP is common to both the triangles. Thus, the two triangles OAP and OBP are congruent to each other by the axiom of RHS congruency. Therefore, by corresponding parts of congruent triangles, PA is equal to PB. Also, angle AOP is equal to angle BOP by corresponding parts of congruent triangles. Similarly, by corresponding parts of congruent triangles, angle APO is equal to angle BPO.